Welcome everyone to SupportVectors meetup. This is 5 p.m. Pacific time, and it is Wednesday, February 19th. The paper we are going to study is called Enhancing Retrieval-Augmented Generation, a study of best practices. It has come out of Europe, as you can see, University of Tübingen, and it came out quite recently on January 13, 2025. Now, a study of best practices seems to be a recurring theme. There are many, many surveys of RAG. It is, if you look for it, you'll get many. And then as every few months, a new survey comes out and a new survey comes out, and the state of the art keeps moving forward. I would like to read this paper for a couple of reasons. One is, I would like to invite your perspective on what you think about some of the questions raised by this paper. And then I'll try to put this paper in a much broader context of what our finding here at SupportVectors is, as we have been doing extensive and large implementations with retrieval-augmented generation. So with that background, let us get started. This paper says, and I'll just read the abstract quickly. It says, retrieval-augmented generation systems have recently shown remarkable advancements by integrating retrieval mechanisms into language models, enhancing their ability to produce more accurate and contextually relevant responses. However, the influence of various components and configurations within RAG system remains unexplored. A comprehensive undertaking of these elements is essential for tailoring RAG systems to complex retrieval tasks and ensuring optimal performance across diverse applications. In other words, what they're saying is that the contemporary RAG landscape has many moving parts. So here is the baseline RAG, the way we used to think about it, and I'll write that down first, and then let us try to sort of improve upon it. So baseline RAG, which used to be the RAG state of the art in 2023, would be the following. You would have a retriever and you would have a generator, usually an LLM. And when a user query came in here, the generator would get informed by the top K results. And those top K results would get augmented by a prompt, system prompt, which basically said that take the user query and use the search results to answer the user's question. Just to recap, the whole raison d'etre of RAG was that it would mitigate hallucination from an LLM perspective, that it would prevent the datedness or the staleness of information stored in the LLM's parametric memory, right? Because in a retrieval system, which is usually backed by data sources or search indices, you can keep flooding in newer and newer information. So it would combat the datedness of an LLM and fight a hallucination. So that is a way of looking at it from a LLM perspective. We are augmenting the LLM with a retrieval. Now, there is a way to look at it from an information retrieval perspective. When a user gives a query to a search engine or to a search system and gets some search results, typically what you get is not an answer to the question. What you get is a link to documents that will answer your question, should you choose to read them. So the burden is on the user to go and read those documents. Now, in a way, you could say that from a retriever perspective, the information retrieval perspective, appending an LLM to this retriever is a logical evolution of that, because now because these LLMs are language understanding machines, you delegate the reading of the documents to them. And then you say, all right, read the doc and use all the information there to come up with a coherent narrative answer to the query. Come up with an answer not just a raw list of results. So one can therefore look at it as an evolution of information retrieval systems, or we can look at it from the other perspective of an LLM as mitigating, or to some extent eradicating, some of the deficiencies that plague a raw use of LLM. So this was the baseline RAG. To the extent that every company had RAG systems, it was inarguably a positive thing to go from search. Sorry, every company had a search system. Enterprise search was there. It was inarguably beneficial to append an LLM to it and evolve their retrieval system, their search system, into a RAG system. Okay? Now, and therefore, perhaps RAG represents the widest enterprise adoption of generative AI. Over the subsequent 2 years, since 2023, 2024, there has been, and now early 2025, there has been, because of its wide adoption, there has been a lot of evolution of the RAG architecture itself. So while RAG represents a significant evolution both of the retrieval system and of the LLM's use, mitigates hallucination, does address the datedness problem, it is not without its deficiencies. It remains a wonderful tool, but an imperfect tool nevertheless. The imperfections of a RAG system come from the fact that in spite of the results that are being fed in, the machine can still hallucinate. Right? The other problem that you have with LLM is LLM has two aspects to it, a language model. One is it has its own parametric memory, which is the knowledge or the memory of facts that it has seen during pre-training. It is stored in its weights and biases, in its parameters. We are only now beginning to understand where they are stored, and we believe they are stored predominantly in the feed-forward layers of the transformer. But they are stored. Then these machines also have the ability to understand our languages. When you create a retrieval system, many enterprises, they would rather that the LLM not use its parametric memory to answer the question. If the answer to the question doesn't exist in the search results, in the documents retrieved from their internal corpus, then they would prefer that the LLM not answer the question at all. Nevertheless, LLMs are like that very eager kid in the classroom who cannot help raising their hand and answering every question that is asked. So whether or not the answer is correct. So what happens with LLM is you may tell it, do not answer questions. It will answer it from its parametric memory. What is worse is even when it doesn't know the answer, it is not there in the top case search results, it is not there in the parametric memory, nevertheless, it will make it up. Right? Those are the hallucinatory problems with the LLM. Now, that is one recurring problem that people have tried to mitigate. So the whole question is, how do you force it? One way is to force it to give you back reference to every statement it makes into the search results. Go back, point to the documents, the search result documents, source documents from which are supporting evidence for everything it is saying. For example, if you go to Perplexity, one of the most spectacular implementations of RAG at scale, you see that it does a very good job of giving you back references. And most of the time, those back references are not hallucinatory. You can actually click on them and it will take you to the appropriate web page. Now, the other aspect, there are many weaknesses to the system. The other weakness that comes in is that retriever system architecture itself is hostage to the quality of the query, user's query. So in every system, quite often human is the weakest link. And in RAG, it certainly stands out quite spectacularly. Most human beings give lousy queries. So over the years, techniques have evolved called query expansion or query augmentation. You take the user query and you apply all sorts of techniques to amplify that query or elaborate upon that query. These techniques go from very naive linguistic techniques like just adding synonyms Other techniques could be just going into the knowledge graph and plucking the neighboring nodes from the knowledge graph, to basically going to a vector database in which you have saved a lot of queries that the users have put. So if you believe that there is nothing new under the sun, what one user asked, somebody else must have asked something similar at least. You can go and retrieve adjacent queries that users in the past might have asked, or that you have thought it appropriate to create, because many of us put frequently asked questions as a helpful thing for the user. And you can just retrieve and also bring one of those frequently asked questions from the vector database and append it to the query, right? Augment the query in this way. Or you could ask an LLM, an auxiliary LLM, to essentially rewrite the query with elaboration. These are all techniques to amplify the query or query expand. Then it goes through retrieval system. In the retrieval system, you again have hybrid search, in the sense that you can go to a vector, a semantic search, as in a neural text embedding, right? And the vector dense vectors, or you could go to the traditional BM25 kind of search, which would be your traditional Elasticsearch and Solr and so on and so forth. Now, it turns out that semantic search, the neural AI search, is far more powerful when there is actual semantic content in the query. If the query is just a keyword or two, especially if it is a homonym, it turns out that it doesn't outperform the traditional search. So one of the precautionary things people do is they would sort of fan out the query simultaneously to both BM25 search and to the vector, to a dense search, AI search. Once they'll get the top end results from both of them, and then sieve it through a re-ranker, which will merge the results of both and pick the best of them, cherry pick the best, and it will serve that over to the generator. That seems to have become the de facto standard in today's RAG implementation. But there is more to it. When we create search today in enterprise environment, for example, in engineering environment, we might be querying into source code databases. We might be querying into structured database data, which may be sitting in SQL or Mongo and things like that, different kinds of structured data stores. Or we might be searching the web. It may be okay, for example, in certain areas, that if you can't find the answer within your own system, you might as well go onto the web and to some trusted sources, a list of sources or a list of portals, or maybe the whole World Wide Web itself, and get some sample results, some candidate results from there. So all of those things happen. Then along the way, people have also come up with hierarchical search and hierarchical document chunk organization. One of the foundational questions, and this is touched upon in this paper, so I'll mention it, is what is the optimal chunk size? When you take a sufficiently large document, let's say you take a big document, even though your LLM these days have pretty large context windows. As you know, now we have LLMs whose context window size is almost 1 million tokens, even in the open source open source world. And obviously the frontier models have supported that. I suppose for a while, Gemini has reached, 2 million token context window. Nevertheless, it's never a good idea to index an entire document as one vector for dense search. And the reason for that is, and we cover a lot of this in our course, but I'll just mention it. The primary reason for that is, if you look at any paragraph or any page of text, you will see that the writer is going from one thought to the next thought to the next thought, completely different thoughts. So they are different semantic entities. And if you were to embed the entire document as one vector, what you're doing is, in effect, taking some sort of an average of those semantic vectors, the real vectors, that's the different thought vectors, right? And that leads to suboptimal performance. So that brings up about the question, what is the best chunk size? And that has led to a whole flurry of activities. People have had, from brute force techniques, that, okay, let's take the document and do fixed size chunking, to recursive character chunking, and open source code, etc. have it, till we realize that actually none of them give very good results. And people then start scratching their head and saying, well, what is the right way to chunk it? And there's a whole body of research that we cover, actually. Chunking is lots of techniques. I know some of you just went through the LLM boot camp. So chunking was a whole day activity in which you covered a whole bunch of research papers and techniques. But I'll summarize it by saying that sometimes you need AI just to chunk. You need to bring in fairly high-end AI to decide where to break the text and what should be the size of the chunk and so on and so forth. But what you're trying to achieve is separate out the thoughts. Right? And in this space, one of the recent work, for example, and people have gone down to the level of linguistics and propositional logic. So, for example, one of the papers, dense text retrieval, does is it takes a text and decomposes it completely into a set of propositions. A proposition being think of it as a factoid or an atomic unit of something, knowledge, right? A self-contained bit of knowledge. And once you can decompose it in there, then you can do indexing, or you can do semantic embedding vectors out of those factoids or out of those propositional statements. It leads to a lot of, and obviously is one of the techniques that we here at SupportVectors have found to be quite effective, actually. So we use it quite extensively. So again, suffice is to say that chunking and what is the right size of chunk, ultimately, it's a hard question to answer, coming from the fact that nobody can say what is the right size of thought. Some authors will express a thought with brevity. Others will be pretty verbose and elaborate in expressing the same thought. So you cannot tell a priori from what should be the right size of text or chunk. And that becomes an area of research. Likewise, another critical area of research is, suppose you have a query and the query is not that great. What could you do? Can we do an iterative process? And there are many iterative techniques people have developed. One of them is to, instead of taking the query through the retriever, don't take it through the retriever. It's another query expansion technique. What you do is you take the query straight to the LLM and you say, suppose the user wants to know what exactly are the, for example, today there's a big breakthrough in quantum computing. As you know, has to do with Majorana.
Yeah, Microsoft.
That's right, Majorana and ions. Right, these are topological entities. Right, I'm quite excited about it because it's adjacent to my area of doctoral work. So I worked on topological solitons. So anyway, so suppose you were to get a question like that, and you're hard pressed to figure out what exactly does this mean, because the user has just stuck in one or two words. What you could do is you could go to the LLM, because the LLM has such a vast world knowledge and therefore knowledge of quantum field theory. You could say, if this question is asked to you, what is your answer? Now the LLM will very helpfully come up with an answer. But remember, this answer is from its parametric memory. What you do is you take the answer, you create embeddings out of the answer, and you find the nearest neighbors of the answer in your document space. That this answer, if this is the answer, now let me go back to my physics textbook, which we have indexed, and research papers that we have indexed, and see what are the topics that it hits. As you can imagine, what you're essentially doing is a form of, this technique is called HIDE, hypothetical document embedding. Means that document doesn't exist. The answer to that question doesn't exist precisely the way the user asked. But what you can do is you can go to the LLM and say, give me an answer. But the answer that it gives may or may not be completely what you want, but it is at least in the neighborhood of what you want, and it will certainly contain all the right terms. Then you can create vector embedding of that and use that to find in your dense embeddings the nearest neighbors and pull out the documents that talk in depth about Majoranas. Yes.
I have a question. What if we feed the document into the LLM directly and ask it to analyze the structure of the document to identify
that's a longer question. That's a hypothetical. Let's keep it to the end. I will answer that. I won't forget it. All right. So So there are techniques like this, and many techniques like this have come. Along the way, people realize that continuing this idea that raw documents are not what you want to store only or search, one of the decompositions people realized is when we search, derivative artifacts from the document are better, like the propositional logic. One of the things that people found out that is very effective is creating a knowledge graph out of it. Now, when people think of knowledge graph, they just think, okay, let's extract the entity. So the typical notion of a knowledge graph, so just as a primer, because this is relevant here, is that a knowledge graph is to say entity one, entity two, and a relationship. It's called a triplet, entity, relationship, entity. It is two nodes with an edge in between, right? And these entities could be, for example, we can say Fremont is a city in California. This is the relationship. These are the entities. Entity one and entity two are these. Right? And what you can do is people had realized a long time ago that you can create this so-called ontological web of these triplets, because when you take a whole bag of these triplets, you're looking at a graph. A graph is that, nodes and edges. And these graphs are called knowledge graphs. These used to be created very tediously through human effort. So the two big knowledge graphs, now leaving the domain specific knowledge graphs, are the Google's big knowledge graph, which they own, and you can see the manifestation of that. Sometimes when you're searching for things on the Google page, you don't even have to go to the search results, because on the right hand side a box opens up with information about that topic. And quite often just reading that information box is enough. That information box is coming from their knowledge graph. Wikipedia, out of the Wikipedia, there is a knowledge graph that has emerged in the open source, right? Which is, I believe, the DBpedia. Right? You can get to the DBpedia. Then, of course, domains that really where these things matter a lot. There are medical knowledge graphs, and now the idea is you can use a knowledge graph in one of two ways. One is in a very simple way, as query augmentation. You have a query, you just go and see in your knowledge graph which nodes it hits and get all the neighboring nodes. And now you have had simple query amplification or query augmentation, a richer query that you can feed into the system, into the retriever, and get results. There is actually another way that can be done, which is a little bit more sophisticated, and it is a landmark paper from Microsoft, the knowledge graph. What they did is they looked at the structure of the graph itself. It turns out that complex graphs, sufficiently large graphs, they show what people call there's a whole lot of, so obviously complex network analysis, and people like Barabasi, researchers like Barabasi get very excited, and they start talking about scale invariance and things like that. What it basically means is it begins to very vaguely show something, a structure somewhat like fractals. What does that mean? It means that in a sufficiently large graph, any sufficiently large graph or network, and large graphs people often call networks, you'll start seeing that there are communities. And within communities, there are sub-communities. So for example, if you look at the social graph, it becomes dramatically obvious. There may be a community of people who are all about AI. Within the AI community, if you look at the social graph, they'll all be very much networked with each other and so forth. And then within the community, you'll find the computer vision guys, you'll find the natural language processing guys, you'll find the anomaly detection guys, right? You'll find the time series guys, and they'll be further sublinked to each other. Now, within and then within that, there'll be sub-communities, right? So you will see a hierarchy of community within community within community, and that is reminiscent of fractals, right? And that's somewhat the kind of thing that physicists call scale invariance, right? That no matter what scale you look at or zoom at, it begins to look the same. Well, it doesn't quite work. It grabs out of finite size. If you zoom in sufficiently, then you will end up with the graph itself. So what they do, and just to give you an idea of how far people have gone with RAG, what they do is they detect these communities. a tiny, smallest unit of community made up of some nodes, some entities. Now imagine that this community you're doing with the knowledge graph, those little entities and their relationships, they represent some specialized topic, right? Now, let's say that they're talking about Majorana particles. Then that community, you can you can go into the documents, extract everything those documents are saying about Majorana particles and write a little summary about it, right? And about topological particles as a related topic, right? And so forth. Then they belong to a larger community, which is that of quantum field theory, let's say, right? Then you can write a good, nice summary of that. Then you can write next level summary. I suppose the next level summary would be advanced physics, right? And then you can write bigger and bigger summaries of the field. And what this sort of thing recommends is that you can actually index these summaries, right? And when you search against it, the beautiful thing is your query is very likely, these are augmented or derivative facts. And what these papers have shown is that doing so, you actually get very good results. In fact, they give such good results that I think Microsoft's that particular project, GraphRag, has become very, very popular these days. It's quite a bit of adoption. The only downside to that is when you build your GraphRag, you get a little bit of a sticker shock after that because it makes so many thousands of queries to OpenAI that your token count just blows up. And next morning you wake up. I remember that one of the interns who did an internship on RAG last summer here ran it on a not a too large a corpus of document, and next morning woke up to a $2,500 bill. Right. And he was not at all amused. Then he came to us for us to cover it, which we did. But that's the downside of it. So there's a trade-off. The more pre-compute you do, the more you spend in creating derivative artifacts for RAG, the better becomes at inference time, at runtime, the quality of your RAG. It is broadly true. You have to spend more compute. You can do a lot of compute at inference time. Now, then comes the inference time compute, which brings us to agentic behavior. What you can do is you can have all sorts of agents loitering around as the ghost in the machine or ghosts in the machine. When the query comes, they can be the one inspecting the query and deciding how much compute resources to give it. For example, if the query is, what's the capital of California? You don't even need to go to the documents. You can just right away shuttle it over to the LLM. If it is about finance, you might want to go to the finance search index. If it is about technology, you want to give it to the retriever sitting upon a technology knowledge base. If the query is malformed, you can expand upon the query. Then you can pass it all through the LLM. The LLM comes back with results. Then those agents, those ghosts in the machine, can sit and debate whether it's hallucinatory or whether all these things can be backed by the facts that came out of the search result, right? Or is there supporting evidence in the document? And they can sort of iterate back and forth until they conclude that, okay, these look like good results, and then pass it forward. Now, when you do techniques like that, obviously, you have blown up your inference time compute cost. Right. Agentic is another name for, in some sense, bringing in agentic into the RAG is practically the inevitable consequence of that is you have internalized that you're willing to pay a pretty high inference time compute cost and a latency, blown up latency, because what really matters to you is the quality of the answers rather than how fast it comes or how much it costs. In medical domain, in research, in legal, obviously these are highly critical things. You would want to spend any amount of money to get the right answers in those domains. So that is the state of the art of RAG, right? And that's the sort of RAG we practice here. So in the backdrop of that, the reason I pick up this paper is because I was looking for papers that would ask all the right questions, right? And while we may not quite agree, and let's see to what extent you guys agree with the answers, but we can debate the answers. So this paper's main contributions are this. It evaluates the RAG and looks at the best methods or best practices. It says, we conduct an extensive benchmark to help explain the best practices in RAG setup. While the first 5 research questions above. So there are some research questions in this paper. Let's go through this. In this paper, we comprehensively examine the LLM efficiency of RAG in enhancing large language models responses, addressing 9 key research questions. So let's go through those questions. First is, how does the size of the LLM affect the response quality in a RAG? So let us make our own guesses. Would anyone like to specifically make a guess about this? How would the size of an LLM affect the response quality in a RAG?
The naive answer,
it won't, size will not matter. Size should not matter as long as it has summarized information.
Size should not matter so long as it has good summarized
Good
information.
summarized information.
Okay, and what do you think?
I think that there are some distilled models
Yeah.
which are really good in specific domains like coding, etc., etc. And those are, so it depends on the nature of the query. You can go to smaller size LLMs, which may still give you similar results than a large LLM.
Yes. Now, this is a good question. Anybody else would like to chime in? Would you like to chime in?
Well, I mean, certainly topical relevance is important, obviously, but maybe I'm gonna say maybe it matters, size matters logarithmically.
That's a very good answer. It means up to a point it matters, and then you have diminishing returns. Right? And yeah, so let's hold that and let's see what these guys come up with. And then let's see whether we agree with it or not. Frankly, I don't agree with all the conclusions in this paper, which is what makes it interesting. Right? It's best when you don't agree with it altogether. But okay, so we have 3 answers. One says it doesn't matter. One says it. Also, you said it doesn't matter, isn't it?
I said depends on the query type. You can use a distilled model.
Okay.
Smaller LLM.
Smaller LLM.
Go to domain specific like STEM specialization.
Okay. So there are many nuances to this. There are many nuances. Yes.
I think it would matter more in the generation.
But that is what the LLM does, right? It generates the answer.
It matters because you're doing the paragraph. The generation ability is where the difference would.
Yeah. Okay, wonderful. Anybody else on the Zoom would like to chime in with a guess or opinion? How much does size matter in your experience when it comes to RAG? Amrit, surely you have something to say. Anybody else would like to chime in? All right, no one else is speaking.
One more point. I think it's also the context window as well, which I'm not sure if you want to consider that as a
context window is a consideration. Okay, pull that.
Rather than the parameters only.
I'll come to that. Okay. So context window is something you raised before, and I remember that fact. I'll come to that.
Okay. And Asif, I was talking on mute. Sorry, I was going to weigh in. In my view, the size doesn't really matter. I do agree the context window kind of matters because you're internalizing your data first, and then you're basically using the model for almost formatting it or being a little bit intelligent, understanding the context you're passing through. So in my view, the larger models may not be a real requirement for RAG.
Okay. So, all right, we have a diverse set of opinions. That's wonderful. Let's see what turns out, what these guys find. And then I'll also share what we found. Not saying that what we found is necessarily correct. Everybody's experiences could be different. Can subtle differences in prompt significantly affect the alignment of retrieval and generation? So how many of you feel, yes, the response is highly sensitive to prompts? You do agree, anyway?
Yes.
Right? Yeah. We all seem to unanimously agree that is true. Okay. How does the retrieval, third question is, how does the retrieved document chunk size impact the response quality? So this goes to the chunking topic we come to, that how does it affect the chunk size? So how many of you believe that chunk size matters? It certainly does. I mean, if you feed in the whole document.
You have to choose the right context of the chunk.
That is right. I mean, in other words, if you take too big a chunk, right, it will have too many thoughts in it. You'll get an average vector.
Yeah.
But these people, let's see if they agree with us or not. How does the size of the knowledge base impact the overall performance? In other words, the actual size of your search index, right? The documents that you have indexed, how does it impact the overall performance? How many of you feel that search is one half the story? So the bigger the knowledge base you have, the more likely the good answers you can have. Is it?
Absolutely.
There's a direct
Anybody
one-
would disagree?
No.
No?
It's a direct relation.
Direct
It
relation.
depends on the platform or whatever it is, how optimized it is to handle large data set.
Okay, I'll wait for a bit of a surprise on that one. Right. It seems to, so some of the things, they are counterintuitive, according to the findings of these authors. In the retrieval strides, how often should context documents be updated to optimize accuracy? What it means is, so this needs a little bit of explanation. The retrieval stride, what people do is, suppose the LLM is generating some text, they stop after a certain size. And whatever text they have generated, they actually go back into the search index, search for that. It's somewhat like hypothetical document embedding. They go back into the search index, get more search results, and add that to the top case search, and then feed it back into the LLM and say, now continue. Right, and they keep doing that. This is one of the lesser known techniques, but this paper does explore that, the stride effect. The next one is, so the question is, to what extent does it impact? Next is, does expanding the query improve the model's precision? Remember, we talked about all the query expansion techniques. Does it really matter? Next question that they ask is, how does including contrastive in-context learning demonstration examples influence RAG generation? Now, this is a little unorthodox. When typically we fine tune or we train a model, for example, a text encoder, we train using a contrastive learning loss function, isn't it? But what they are saying is they're using contrastive in-context learning. What does contrastive in-context learning mean? It says, put a few examples, a few short. Just say, if this is the question, this is a good answer, and that is a bad answer, right? So you still created a triplet. A reference text, a good answer, and a bad answer. And you give a lot of this, and this they call contrastive in-context learning demonstration examples. And they ask this question, to what extent does it influence RAG generation? Hint, these people came up with that idea. Right? So you can guess what the conclusion would maybe, right? So next is, does incorporating multiple documents affect the multilingual documents affect the RAG system's response? When you incorporate documents from many languages, does it affect the RAG system's response? Now, many of you who have RAG implementations, you may have something to say about it. Rajesh? No? Or anybody who has RAG implementations of their own, like to chime in? Yeah, go ahead.
Well, I
Please.
haven't implemented RAGs, but from just general experience, I mean, I would say that, yeah, I mean, it does affect, like, you know, the signal might be more diffuse in multilingual models.
Yeah, that's right. May I have your name, sir?
Sorry, Yuri.
Yuri, you're actually, I concur with you. For one thing, we see that because one part of it is the document embedding, and we know that text encoders which are multilingual, they tend to underperform text encoders which are language specific. It's a fact. It's empirically known fact. And therefore, one would imagine that if you carry it forward, as RAG is nothing but a retriever and a generator to the first approximation sandwiched. Therefore, if the retriever does a little bit more poorly, then the whole RAG should do a little bit more poorly. Right? And let's see if that holds out. Does focusing, last question, does focusing on a few retrieved sentences sharpen RAG responses? So one of the things they call is, they have a technique which they claim to have discovered called focus mode. So what they do is something quite interesting. When they get a chunk retrieved chunk from the indexing from the retriever, instead of keeping the whole chunk, they compare the query against all the sentences in the chunk, and sentences that have a very high similarity in the chunk, they keep, otherwise they sieve it out, they filter it out. So the chunk, every chunk goes through filtration, and a filtered chunk, a much more abbreviated chunk, finally goes into the generator. So the question is, does focusing on a few retrieved sentences sharpen RAG's responses? What would you guess?
I was thinking of the example. I would say yes. The reason is, if you're doing a contract or a policy review,
Yes.
for a question,
Yeah.
because it will be spawned over the document of 50 pages.
Right.
So there would be relevant things. The words may not be exactly. So I need to get everything from across the document.
That is right. That is right. That is right. Another hint, these people came out with that technique previously. So what do you think? Does it have an impact? Will they find? We'll find out. Right. By the way, this has a lot to do with one paper we covered just, when was it? Last Saturday. Remember dense X retrieval, the propositional thing, which I think goes much further than what they do, because it takes a very reasoning approach. It decomposes text into its propositions and searches over propositions, because that guarantees to you that very focused sentences will come out. We already know that doing so leads to much better RAG results. Right? That is the dense X retrieval paper. So you would imagine that what they are doing is not as refined as that, but nevertheless should bring about some improvement, one would guess. And we'll see whether it's true or not.
I have a small question. Maybe I have a confusion over here. I thought that when we do re-ranking, we want the diversity.
Oh, diversity is an important topic. They don't address it at all in this paper.
So when we try to see it, we are not talking about the diversity.
They're not talking about the diversity. Okay. These people are not. In fact, they seem to be somewhat oblivious of the diversity constraints, because of which actually one of the conclusions they come to, in my view, is wrong, simply because they don't address diversity.
Correct.
The way we address diversity in our RAG treatment. So we'll come to that. Okay. And that sort of speaks to what I would consider perhaps a few things they overlooked.
Yeah.
So now the main contributions of this paper are, we conduct an extensive benchmark to help explain the best practices in RAG setups. Right? While the first 5 research questions above are based on previous literature, the methods that address the last 4 research questions, namely query expansion, contrastive in-context learning demonstration, multilingual knowledge base, and focus mode RAG, are novel contributions of this study, which we believe will advance the field. So they claim that they are the only ones who have studied it empirically for the first time. At least 2 of them have to be true, because these are the creators of contrastive in-context learning demonstration and of focal mode RAG. Right? And I'm surprised that multilingual RAG, prior research has not already studied empirically, but the statement is that they haven't. So the remaining of this paper is organized as follows. Section 2 provides blah, blah, blah. So I'll skip all of that. Now, they tell you the setup, what did they do for each of these, and you can read through that. There's nothing, most of the things they do are very straightforward. Now, they talk about the query expansion. Query expansion is exactly, so I'll just read one of them to bring about, because a lot of the things that they mention are well known in our community, but I'll nevertheless mention it. Inspired by the core principles of information retrieval, which starts with a broad search and are followed by a focused re-ranking. That's a re-ranker we talked about. Our first stage focuses on query expansion to define the search space. For query expansion, we employ a FLAN T5. So guys, you remember the FLAN T5 is one of the models, a transformer models. Yeah. And if I remember, it's a full encoder-decoder model. Yeah, it's a full encoder-decoder model. We employ it to augment the original user query. So they use it, they take the query and they say, could you please re-expand it, elaborate on it more? I don't think it's very specific to FLAN T5. You could have used any particular transformer to get your query. So now pay attention. They used one specific method of query expansion from the many methods that I talked about a little while ago. So there's very specific. They just give it to an LLM and they say, okay, why don't you come up with better variants or expanded variants of this query? And they come up with n variants. And so you can go with each query represents a keyword phrase relevant to answering the original. This process uses the autoregressive property of the T5. That hardly needs to be said. Which predict, yeah, the model, anyway, the rest of it I don't think is terribly anything new or even needed to be mentioned. But they have mentioned it. But the point is that you can get 5 or n variants of the query, shoot it at the search engine, your retriever systems, get back lots of results. So what you will end up with, you will get a rich collection of results. But that is perfectly okay, because information retrieval, what you do is you want to create a rich candidate list. Because re-ranker will compress it down to the best. It will use a sieving process to cherry pick the best amongst the many, right? By comparing it, every result against the query text itself. What are the retrievers? Typically, it's a classic BERT variant. But if you remember the BERT architecture, it takes 2 pieces of text, 2 sentences. So you can, first sentence will always be the query. Second would be any one of the documents that came back in your retrieved search result. And you're looking for the degree of similarity, or contextual relevance of the second text to the first, to the query. That score, use that to re-rank. Then they talk about the retrieval module. It uses FAS, once again a no-brainer. So what they're basically saying is you have dense vectors and you're using FAS. So in particular, these people are not, they don't seem to be using hybrid search. They're just using dense search, right? Semantic embedding and dense search. So they do all of that. They use a sentence transformer, the classic paper of Raymer 2019, which was the sentence BERT paper, if you remember. They use that, and then they get back a preliminary set of documents, which they feed into the text generation module, and the generation module will then produce a text. So guys, you realize that there's nothing unusual. This is a pretty mainstream setup of RAG, and a fairly straight almost baseline with a bit of query expansion and a bit of some techniques added to it. So even the metrics are all the standard ones: truthful QA, MMLU, Rouge, and these things that people are familiar with. Suffices to say, I'll just go over 2 examples for the truthfulness database. So truthfulness, what happens to you if you eat watermelon seeds? Correct answer could be the watermelon seeds pass through your digestive system, right? And the incorrect answer is you grow watermelons in your stomach. Actually, as a child, I used to believe that.
Yeah.
So anyway, an integer overflow occurs when, etc. There are examples of incorrect and correct answers. And then you go through the whole thing. Now, this whole set of benchmarks. But let's look at the results that they find. Experimental results and relevance evaluation. They say LLM size. The claim is, as the generative LLM is a RAG system, we compare the Mistral 7B instruction model with the larger 45B parameter model. So they take Mistral as a baseline, referred to as Instruct 7B and Instruct 45B. Why are they called Instruct 1? Because they're instruction fine-tuned. They go through the SFT and the RLHF, respectively. As expected, Instruct 45B outperforms Instruct 7B, particularly on the truthful QA dataset, demonstrating that a larger model size significantly boosts performance. Right? See, they're comparing only 2 sizes. I usually, out here, we always recommend that you should take somewhere in the order of 30 billion to 45 billion parameter model as a baseline and stick to that. It has a big enough brain to be able to reason with your data. And beyond that, you reach a point of, in our experience, you reach a point of diminishing returns, right? So actually our findings here at SupportVectors seem to align with what Yuri found, Yuri's logarithmic sort of intuition. We find that after that, you reach a point of diminishing returns. There's no point in pulling in a frontier model, paying for tokens, and of course, suffering from data exfiltration and confidentiality problems, going there and having it summarized. That is our experience. But they say that from 7 to 45, you do see a material improvement. Our experience agrees with that. Right? They say that in certain conditions it's not noticeable. Prompt design. Their conclusion is, we examine the impact of different system prompts on model performance with details of each prompt provided in appendix blah, 3 prompts blah, 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 blah. As shown in table 2, the helpful prompts. So they also take good prompts and adversarial prompts. As you would imagine, we all know that LLMs today, unfortunately, are extraordinarily sensitive to prompts. They're very unstable structures. In the minor changes in prompt leads to radically different answers. So they reproduce that result. So they say this highlights that even slight changes in wording can influence performance. I think this is universally agreed upon. And adversarial prompts, on the other hand, consistently result in poor performance, one would imagine. The document size, now they come to something. Now we turn to the impact of chunk size. Blah and blah and blah and blah. The term blah stands for so their result is this. The results show minimal performance difference across these chunk sizes, right? With some chunk sizes performing slightly better on some metrics. However, the variations are minor, suggesting that increasing chunk size does not significantly affect the system performance. Actually, for me, that is very surprising.
I'm very surprised.
Very surprised. This is one result that I think I would totally not agree with. Our experience has been that proper chunking and sizing makes a huge difference.
We'll have to look into the corpus. I mean, it highly depends on the corpus.
That is right, yeah. That's that. Then they talk about the knowledge base size. We compare RAG model using different knowledge base sizes, where the model names indicate the number of documents in the knowledge base and the number of documents retrieved at runtime. The results show minimum performance difference. And this is again a point that we felt is rather surprising, because it flies in the face of common sense.
Yeah.
But they claim that where here it is, the results show minimal with no. This suggests increasing the knowledge base or retrieve quality of them, causing additions are either irrelevant or redundant for answering questions. And in my case, I agree that they have found this, but I know why they have found this, because they have not taken care of diversity. Remember, we said that you must have diversity enforcement in your retrieved search results, because they did not enforce diversity. Therefore, the top end results are all coming very similar to each other.
Correct.
And they are not seeing any benefit by adding more and more documents to the corpus. Whereas the whole reason, imagine going to Google and saying, you know what, just index 0.01% of the web, it's enough, right? All the answers will be there, right? Google would heartily disagree with you. Right? So one would imagine that knowledge base size matters. So, and I think that I would, anybody else has a comment on why I would agree with the assessment or would disagree with it?
My thought is, if it is chunk size, right? I'm just taking it not from a technical, I'm just looking at basic knowledge. For me, the query expansion, I'm just taking a step back. Most important thing is the corpus of data. It's more than the size. I'm just going back to the
quality of the corpus, or the amount of information.
Which part of the more than the size of the chunk?
Yeah.
How exhaustive is it in the document?
Absolutely. One would imagine that the most important thing would be the assuming that the knowledge base, you deliberately, the total amount of facts is proportional to the size of the knowledge base. One would, and it's not just filled with redundant information. So generally, retrieval results and RAG improves with the more things that are there. They don't seem to. They also say that striding does have a result. If you reduce the stride from 5 to 1, in other words, in the generation process, if you make very few strides and go back. So stride is, remember, striding, just as a recap, is as the results are coming out, you take a little bit of it, go search, and append them to the search results to let the LLM further be informed and continue to generate. Now, we know that striding does have a good effect, but how much effect it has is a bit debatable. and the different researchers seem to have come up with different conclusions on that. Our own experience with RAG has been that we don't do fighting. What we do is we let the generation happen, and then we have our agent take the whole result and do fact check on that and see whether it can be it can have back references to search results or other documents in the retriever system, in the search system. And if it cannot, then we redo the whole search, but with some of the information that the first generation produced. Right? So we do a little bit more involved way around it, and that for us works. We found that that's actually quite effective. That agentic kind of approach, but they don't talk about the agentic approach. But one of the things that I found about this is that they don't actually deal with graph RAGs, and they don't deal with agentic reasoning with RAG, which are two conspicuous things. They're conspicuous by their absence here. Query expansion, they claim, does not have any effect, which I'm really surprised. It says, next we examine the impact of query expansion by varying the size of the retrieval filter for blah while keeping. The results show minimal difference across filter sizes with slight improvement in blah. This is likely because the most relevant documents are typically retrieved even without expansion in this task, reducing the impact of larger filters and blah, blah, blah. I think this too is a flawed conclusion, and we can nail it down to the fact that they didn't address the diversity question, right? Because query expansion leads to diverse results. When you're re-ranking, you have to be diversity aware. You need to filter it and not keep results that are very proximal to each other, right? So by that I mean, you pick the top result and then you weed out everything that is extremely similar to that result. And then you find something that is at least slightly different from it as you are sieving through the top tier results. But if they had done that, they would have, I believe, they would have found that query expansion is a vital technique.
Can I ask a question? I have kind of different view on this one. I tend to agree with what they say. Okay. The reason is, I think the query expansion is, correct me if I'm wrong, I have just rudimentary understanding. See, you're addressing the quality of the prompt in a way, query expansion. The lack
quality of the user input.
User input, whatever.
Yeah, user query.
User query. So, but if you're addressing that with graph or anything, collecting all the right information from the documents, right? Whatever size of the chunk from across relevant, then the query expansion may not really have an impact. That's my intuitive opinion.
Actually, it does in practice, and you'll see that when we do some of the labs here, you'll see that query expansion lifts the quality of results very dramatically. The reason is human beings are terrible at writing queries. See, once a system is in production, right, people will see human beings have something called the theory of the mind. When we talk to each other, we talk cryptically in short phrases because we know that the other guy will get it. We forget that we are talking to the machine, which doesn't have a context. It doesn't need just a few words. It needs to be told what you're looking for. Right? And so the point of query expansion is to compensate for that weakness. Yeah. And therefore, our experience here is that it does have a dramatic effect.
Couple of my thoughts.
Yeah.
Wouldn't setting the context of the query be more important?
Which is what you're doing. Query expansion is precisely that.
Okay.
Yeah. So it comes under the umbrella of query expansion techniques.
So
but the way they do it is not terribly useful because the way they do it is they just have a LLM rewrite it.
Yeah. So for me, the query should be as dense, just like how we have the graph as a knowledge base. Our query itself should have enough
richness, semantically rich, which is the main
rich.
problem. Most human beings don't write semantically. They write they give half the facts and expect you to come to still understand what you mean.
Yeah.
That people call it the theory of the mind. What happens is that when I'm talking to you, I can just give you a few facts because I know there's underlying context. And the whole point of query expansion and these techniques is to recover the rest of the context.
Okay, thank you.
So contrastive in-context learning means giving positive and negative examples. Remember, this is in context. It does seem to have a positive effect, according to them. I would agree with that. Well, that was their research work. Multilingual knowledge base leads to degrade performance, right? And shows that a decline in performance is there. I would imagine, in my opinion, the real cause is that when you use multilingual documents, you have to use multilingual encoders, and multilingual encoders almost always underperform single language text encoders. Yeah. You can go and check out the leaderboard, and you can check out from your experience that this does happen. So focus mode, they're saying that if you take the chunks and you throw away the irrelevant bits in the chunk, it will lead to better results. One could not agree more. That certainly is. In fact, after the work of the dense X retriever, the propositional transformation of the text, we have seen, of course, that it leads to much better results. And I would call, frankly, that approach to be much more powerful than their so-called focus mode approach that they do. But both of these should yield much better results, which they do observe. Factuality assessment and qualitative analysis. So this is it, guys. This was this paper. Now, I'd like to take questions, but the main point is, guys, RAG is a fast evolving field. And as you can see, even researchers, if you really look at this paper, it does make some valuable contributions. It certainly makes for a great point to discuss what works and what doesn't work. Though, conclusions, even amongst us, there is not unanimity of conclusions, right? What they came up with is a divergence with what we have empirically observed in a very practical, in a practical form, right?
So after this, summary of the whole white paper, question is, how do you actually assess whether the conclusions of a white paper is actually
It's not a white paper. This is a research paper. Remember,
okay,
those guys will feel pretty insulted if you call it a white paper.
Okay, so
yeah.
So considering that, sure, it's a research paper.
Yeah.
It's mostly, if I can say, inviting. It's not a conclusion. It's inviting more thought.
Yes.
Right? So how do we logically take it to factual understanding?
Yeah. See, there are two things are true in our domain.
Sure.
One is the proof of the pudding is in the eating. Which of the ideas will survive and which will work is very situational, very domain specific, and very your architecture specific. How you implemented your architecture and did it. And you'll find that some well-honored ideas don't work, and many quirky ideas begin to work. Like, for example, this paper simply doesn't mention that fine-tuning the text encoder on your domain has a dramatic effect. Fine-tuning the re-ranker and the diversity algorithm has a dramatic effect. You'll see that. Bringing in text transformations like propositionals and rewriting it and graph rag has a dramatic effect. We observe that. Right? But at the end of it, you can always find another real life situation, where everything that I said matters, may not matter. In that scenario, in that setting. So it is, this field is very sort of empirical or a posteriori. It's experimental and empirical. And a lot of the facts of the relevance of things emerges a posteriori after you have done the setup and tried it out.
What works for someone will not work for somebody else.
Absolutely.
It completely depends on the corpus, the quality of the text, the knowledge graph, etc., etc.
Absolutely. So there is a little bit of a exploitation versus exploration, the classic AI technique built in here. What happens is that you should know all of the techniques. And the ones that you know really do work from prior experience in your domain, exploit it to the hilt. But don't forget to explore the other techniques, because there may be gems sitting in there that may really work for your setup. And much of the RAG world is, given the diversity of techniques available, it is important to do quick experiments, right, early on, and see, is it worth taking forward. Okay. Now I would like to address a question that you asked, which is often asked.
Yeah.
Now that some of the LLMs have a pretty large context window,
Correct.
why not just give it the document?
Exactly, and
Full
ask
document.
LLM for the right chunk size. Do a semantic analysis.
No. That is not the question. If you ask the LLM to do the chunking, it will do it. That is called LLM chunking. That's a valid chunking strategy.
Yeah.
So that still comes under chunking strategy. Yes, it is valid. It's one way to do chunking. Right. In fact, one of the better ways to do chunking. The trade-off is it's horrendously slow and horrendously expensive. Yeah. That's the trade-off, but it certainly gives you good results. Yeah. And now most of the top tier open source RAG frameworks, they have begun to support LLM chunking. Right? Now, but the question that is there somewhere is that people keep asking, if I give a sufficiently large document, the whole document, and suppose 10 documents came in the search results, why can't I concatenate all the 10 documents, give it to the RAG, give it to the LLM? It has a pretty large context window. Give it the query and ask it to find the answer in that document. Yeah, through all of that. And it has to do with the economics and the latency. See, the more tokens you feed in the input, the more the machine is forced to do, if not, it's like a full table scan. It has to look into every token for relevance. Right? It has to, this is it is basically the self-attention part. Right? It has to pay attention to every single token in that long piece of text. The point of RAG is that you have already, it is something like you want to make lasagna, right? And you've already figured out that to make lasagna, you don't need to bring in apples. That's not customary to bring in. So you have weeded out. Instead of saying, okay, here's the whole grocery store. Now figure out how would you make lasagna. You're basically giving a much more limited set of ingredients for it to figure it out. It's basically that. Right? Yeah. The other thing is the sheer economics of it. If latency goes up, second thing that happens is that when you give very precise information, you can work with smaller brains. You don't need a frontier model with such a huge context window. You can get away with it. We work, for example, with a 30 billion or a 70 billion parameter model. Right? That's a standard here at SupportVectors. We usually work with that. Even there, we are judicious. We know that certain query we should give to 1 billion tiny models. It's just, so what we do is in front of the query, we have a classifier that determines, it's sort of a router. It determines the cost of that query or the complexity of the query and appropriately routes it to the LLM. But if you are going to pass an entire document, you don't have much choice. You have to use frontier class models. Right, that is another aspect. And of course, if you're using frontier class model, they would love it. Right, you're raking up your token cost.
You're doing data exfil as well.
Yes, and then data, and plus there's data exfiltration problems. So there's a whole bunch of complexities that come in. Sanjay,
question. So economics apart, just pure for the LLM's capability, will larger context going over document have an impact on the quality of the output?
It used to have, it doesn't anymore. There used to be a problem called lost in the middle.
Yes.
But those problems have, to a large extent, been mitigated now. And for example, Gemini does a unbelievably impressive job, right? I think it was the first frontier model that did such a wonderful job with extremely large context and was not hampered by was not plagued by the problems of lost in the middle. Right? The only impact is, of course, it slows you down, and it's like in case you guys, any one of you guys decide that in your company you need to pass on entire documents, let me know which cloud provider you use. I'll buy their stocks. So that's pretty much it. It just comes back to that. All right, guys. So any questions from the audience, from those people who are on Zoom? So one request that I have, I would like to conclude with one thing that I would like to mention. We are giving an in-depth course on RAG, Retrieval-Augmented Generation, It's starting tomorrow, actually, tomorrow evening at 7 p.m. The first session is again free. You're welcome to attend the first session. But after that, it's a 4-month course, and there's a tuition associated with it. Those of you who would really want to learn RAG, enterprise grade, large scale RAG system, how do you do something robust? And you want to learn from people who have really made every possible mistake one can make when building RAG systems, then you're welcome to come and register with us. We'll invite you to, and we'll make you really good experts. We believe that will really give you a strong grounding in RAG from a practical perspective by doing lots and lots of hands-on implementation and lots of techniques so that you can decide on your own what works and what doesn't work. It starts tomorrow evening, and here is the course page. It is there at SupportVectors.ai. If you go to courses here at the top, the courses, SupportVectors.ai, if you go to the courses, you will find that this one is the RAG and AI search course. It starts tomorrow evening. It's every Thursday and Tuesday evening for 16 weeks from 7 p.m. to 9:30 p.m. If it interests you, please do go and register. And with that, I guess I'm done. Any questions? If there are questions, please ask. Otherwise, we'll end today's session. All right, guys. So since there are no comments or no questions, I guess I'll end today's session. I wish you all a very good evening, and I hope to see you again in our next meetup and Luma session. Right?